this video, I want to show you how to write the Kc and Kp expression for equilibrium reaction. We are talking about chemical what equilibrium. Now, when we talk about chemical equilibrium, this type of reaction that will occur in what in a reversible what reaction, where the reactant moves to the product or produces the product, while the product also move backward to the reactant, right? So when the rate of forward reaction is equal to what rate of backward reaction, we say the reaction is at what is at equilibrium. And that type of equilibrium is known as what dynamic equilibrium. So these are stuff you really want to understand. So now every equilibrium reaction, I will call what we call Kp, what we will call Kp and what Kc. Now the K means what the equilibrium constant. Together, so this K means what equilibrium constant. Here also means what this K means what equilibrium what constant. It's okay. Now this P means what for pressure, right? So here we have pressure. Here we have what this C means what concentration. So what we want to understand here is that Kc means what equilibrium constant in terms of what concentration of the reactant and the product. Then Kp means what equilibrium constant in terms of what pressure. Do you do that? So now for every equilibrium reaction, we have what called the equilibrium equation. Do you get that? Writing the equilibrium what equation. And when writing equilibrium equation, now you must write a balanced chemical what equation. That is the equation what must be what balanced in a reversible reaction here. So like this type of what question I see here, they say you want to write the Kc and Kp expression for the what this following set of what reaction. So I want to teach you how to write the equilibrium constant for this reaction in a few minutes. So, but I want you to understand the fundamentals first. So, if for example here we have a reversible reaction, the state of the species, either the reactant or the product, matters a lot, because we have called homogeneous mixture or homogeneous reaction where we have all gas phase, but in an heterogeneous equation where we have solid, liquid, gas, or aqueous. Now these are stuff when this become complex. So I'm going to show you a general what reaction here. So here we have, if you have something like A gas, B gas, then we have what C gas plus what D gas. If you have something like this, they are all in a gaseous state. Now what I want to put in mind is that when writing a equilibrium constant expression, now the concentration or the pressure of the gases are made use of. You understand? So now because they are all gases, we can make use of them. Then the format here you have Kc equals to what the concentration of the products of the products raised by what coefficient over what concentration of the reactant raised by what coefficient. Right there. So this is a format where you use to write the Kc expression. Now Kp also is same as what here we have pressure of the product. Pressure of the product raised by coefficient over what pressure of the reactant raised by what coefficient. It's okay. Now, this coefficient you are seeing here is called balance what equation. Do you get that? So, Kc make of the concentration. Now when I see a square bracket in chemistry, it's not what concentration. I will know that the unit of concentration is what is mole per dm cube. Do you understand? The same thing with the other one here. This one is what is pressure. The pressure I want to use here is atm. Do you get that? So let's try for this one here because this is called homogeneous mixture. We have all this. We have gases. So if you want to write here we have what the product here. So it will be Kc equals what concentration of here we have two product C and D. So it will be concentration of C gas, guess what? C, right? Then concentration of D gas, guess what? D. Can you see that over what? Concentration of A gas, guess what? A. Then we'll concentration of B gas, guess what? B. Can you see that? As easy as that. Now, when how do you write for KP? KP is C same thing here, but it's going to be in terms of pressure. So it's going to be pressure C gas. Guess what? C. Then pressure of what? D gas. Guess what? D over pressure of what? A gas. Guess what? A. Then pressure of what? Of B gas. Guess what? B. Can you see that? You can see how easy it is to what to write equilibrium constant expression, especially when it is what the when it's what homogeneous. Do you get when it's what homogeneous? Now, what about if they are not on the same state? Whether what about if you have solid, liquid, or gas in that equilibrium reaction? How are you going to write the equilibrium constant expression for that type of reaction here? So, what I want you to understand here. Now, one thing you need to understand here is that if, for example, here we change it to what? To solid. Idea, we change it to what? To solid. Now, let us imagine we change it to solid here. Now, in writing a equilibrium constant expression, which also know as what? The mass action, which I didn't tell you, you also know as the law of mass action. Now, in writing equilibrium constant expression here, what you want to put in your mind is that the concentration of solid and liquid are always constant. You get that? Because the always constant is always regarded as one. Understand this here. Concentration of what? Solid and liquid are always equals to one because they're always constant. So they are not be used in writing equilibrium constant expression, either for the Kc or for the Kp. Now, but the concentration of what? But the concentration of gas and aqueous are used. You always use them. Do you understand? So when you have something like this, now it contains gas and solid, right? So let's write it the normal way. The normal way of you writing it is going to be Kc equals to what? Concentration of C solid. Guess what? C. Here we have D gas. Guess what? D, right? Over what? A solid. Guess what? B. Guess what? A. Then what? B gas. Guess what? Guess what? B. Now, these two are solid. The concentration of solid are always equals to one. You get, because they are always constant. It means that what it means that concentration of C solid is what is one. Is what is one because it's what is solid here. Do you understand? Then concentration of A gas of which solid equals to what? One. So if she imputes one, yeah, then any I see my gas, my solid, concentration of solid of C and what and A, I want to what impute one. So it will be Kc now equals to what? One times this. So yeah, remember anything is for one. No, if I have one here, right? If I have one here, this one is useless. Do you understand? So it does not count. So it's going to be concentration of D gas gives what D what concentration of B gas gives what B. This is that. So we don't use this two here because the main reason why we don't use this two here is because it is what they are solid, right? And the concentration of solids when writing equilibrium constant expression are always equals to what? To one. So you don't make it of it. If you want to write the Kp expression here, Kp is the same thing here. So it's going to be pressure of D gas. Guess what? D. What? Pressure of what? A gas. Guess what? A. Guess what? A. Do you understand now? So this is how to write the equilibrium constant expression. So let's start writing this stuff here so that you understand better. Now let's take the first one. So we have to write the Kp and Kc expression for this what reaction here. So now when a question like is given to you, first you want to do is to what? Is to checkmate if the equation is what is balanced. Because most times the equation may not be balanced. So if you should write like that, then you're not going to what get the answer. So if you look at this question here, N2 nitrogen is 2, IDG is 6, IDG is 6, so it is balanced, right? So my case expression here equals to, remember, I'm starting what the product, right? So ammonia are going to be, because here we have gas, right? So you make it of it. So it's going to be concentration of what? NH3 gas. This what? Can you see that? Over what? Concentration of N2 gas. This was what? 1, but they don't put one there, so ignore it. The concentration of H2 gas. This was 3. That is it. You can see how is it to write the law of mass action or the equilibrium constant expression for any for this first one, right? The same thing I'm going to do here, Kp is going to be what? The same here, but you're going to be what? Pressure. NH3 this about gas this about 2 over pressure N2 gas this about 1 they have pressure H2 gas this about 3. It's okay. So can you pause the video and try this B for me? I want to see what you can do. Pause the video and try this B. I want to see what you can do if truly you understood what I have done here. So pause the video just a minute and try that B for me. Okay, so let's write the equilibrium constant expression here. So first of all, let's check if it's balanced. One carbon, right? Then here we have one oxygen, making what 2. Because half times 2 is what is 1, right? So it's coming together. So this question is what is balanced. So how do you write the case expression? Remember, they are all gases. They are all what? Gases. So it's homogeneous. And the concentration and the pressure of gases are making of when I take equilibrium constant expression, right? So it's going to be Kc equals to what? Concentration of CO2 gas, right? Over what? Concentration of what? CO gas, right? Then what? O2 gas. Can you see that? So that is it. It's very, very easy. So the same thing here, Kp equals to pressure of what? CO2 gas, right? Over what? Pressure of what? CO gas. They have pressure of what? O2 what? Gas, right? So which is going to be what? 1 over what? 2. So you can see how easy it is to really write what the equilibrium constant expression is very, very, very easy. So let's look at what the C part. You can also pause the video and see how you can write this C for me. Let me see what you can do. Of the composition what reaction, right? Now what you want to understand here is what solid, here is gas, right? So the concentration of the sun is 1. So normally if you want to write the what Kc expression, it's going to be what? Here we have the products. Here we have NH3 gas, right? Here we have HCl gas, right? Over concentration of NH4Cl solid. It's okay. But we don't make use of it. We don't want to make use of it because when it is solid, you can get it as 1. So there's no point of adding it here. So just write it out. So this is what the Kc expression. Do you understand now? So the same thing with what Kp. If you want to write the Kp, it's going to be what? PNH3 gas. Here we have what? PHCl gas. Do you understand? So that is it. So if we have come to the end of this class, if you follow up or you understood what I've done here, leave it at the comment section that you actually what follow. It goes a long way to tell me that you that watching this video, you actually what following, and this video is helping you. Do you understand? And if you're not subscribed to the channel, please hit the subscribe button and turn on the notification bell because you don't really want to miss out any video content upload on this channel on a consistent basis. It helps a lot. It helps you a lot to cover some important topics that you are supposed to straight yourself with your own. Do you understand? So watching this video actually will give you that leverage to cover the topic faster. Do you understand? If you have any question, leave in the comment section. Please, you can kindly share this video to your friends. If you have not watched our class principle, we explain the effect of our concentration, pressure, and volume on the equilibrium reaction. So you can check out this video. I will see you there.